Now imagine if we have a network service and if we combine the monitoring or the assurance of that service as part of the life cycle of that service, we will be able to diagnose the errors or the degradation of the issues of that service much faster. The mean time to detect and also in real time, in almost real time, we will be able to find the root cause of the issues. That's what we will discuss today in Crosswork Automated Assurance using Crosswork Network Controller called a CNC and Accedian. Hi, I'm Farooq Muhammad. I'm a technical marketing engineer in the Cisco Crosswork BU. My focus is on CNC and Accedian along with automation. So now, why is there a need for service-centric proactive assurance? Now, if you look at traditionally the way we do things is provisioning portion and managing the service is disjoint with that of the monitoring or the service assurance portion of pieces. What this means is that because these two, what it means is because they are not in sync, then it's difficult to correlate the errors that we see to a specific service. Now, if we have a service-centric approach and we tie the assurance pieces and the management of the services together as a unified network service, then we can proactively manage that service and also get any errors on that service immediately. What this does is the quality of experience also improves for the end customers. And the quality of experience from an end customer is it possible to mitigate issues even before they occur, right? And if so, that is fantastic. Or sometimes that's not possible. And if there are any issues, is it possible to identify that issues in near real time? Because we all know that identifying the root cause is the major thing. Once we know what it is, it's the finding the solution for that is easier. So that's if we make it service centric, that makes it easier. And with this approach, we can associate SLAs to that service by defining the KPIs and the thresholds. And if any of the thresholds are exceeded, then that for that specific service instance and the subcomponents of that service, the errors will be raised such that we do not need to sift through error logs to find out where the issue is. And that's how the mean time to detect and in near real time we can identify the issues. Hey, which means we don't have to roll out trucks to go to the fields and fix those issues. So let's look at the very high-level architecture of Crosswork and Skylight integration. Now, the Crosswork is in terms of for the configuration of the services and also establishing the test sessions. Here it's the TWAMP sessions. We'll discuss that in detail later. Is all done by Crosswork. So once we have the TWAMP sessions running and we collect the telemetry, that telemetry information is by the Skylight sensors, which is in the Skylight sensors are where the TWAMP sessions get established, and the Skylight sensors are established through the network service that we are monitoring. So the telemetry from that information, so the telemetry from the Skylight sensors is then sent to an internal collector in Skylights called as a Roadrunner, and then it goes into the Skylight orchestrator, and the Skylight orchestrator then sends it to CNC through the CDG, and it uses GNMI to send it to that. So that's a very high-level view. So let's look at more detailed components of the Skylight solution. So let's discuss the reference model. So Skylight comes in different flavors. If you look at the top right, it's one is there's a one box which is in a gray. It's called as on-prem. So it comes in an on-prem solution which is called as Skylight Lite, Lite, and the other one is the cloud-based one called Skylight Analytics. And for CNC, we use an on-prem solution. So the on-prem solution basically consists of agents which can be run on SFPs or on x86 Linux containers. And they establish test sessions between the agents. And these test sessions are follow the same path as your network service. That's how we can know the issues in your network service. And the telemetry information from that is sent to a collector, which is referred to as a roadrunner in Skylight. And from that on-prem collector, it can be sent directly to the Skylight Analytics cloud through a TCP using port 443. So that way you can go through firewalls. And for the Skylight Analytics, you can use the web UI or you can use an API to access that. So the diagram just below that on the bottom right corner, that's the reference architecture for CNC and Accedian. So here we use the Skylight Lite, which is an on-prem solution, which is a lightweight Skylight server. And the way we do the assurances, for example, so here the dotted blue line shows the path between two sensor agents. So PE01 and 03 are the network service endpoints. So there's a TWAMP session established between the sensor agent associated with PE01 to the TWAMP session associated with PE03. And that telemetry information is then fed into RR, the collector. And from the collector, it goes into the Skylight Lite orchestrator. And Skylight Lite orchestrator then sends the telemetry information using GNMI to the collector data gateway into CNC. And then CNC then correlate the telemetry information for that specific network service that it is monitoring. And it also checks against the thresholds that have been specified. And if the thresholds have been exceeded, it will raise alerts for that. Not only that, there's also a visualization aspect of that where it builds a graph. And in that graph, you can know exactly which subcomponents of your service is affected. And that's how we can identify the root cause in near real time. And the service and the sensor agents, they come in different formats. There's the popular ones are the SFPs, or they are the x86 based containers. So in CNC 6.0, which is the first release of Accedian integration with CNC, we are using the container-based approach. And you can define the topology of the Accedian agents in different topologies, including mesh, hub and spoke, where you specify the hub and the subset of the PEs, which are the spokes, or the custom, which is the point-to-point where the end user can list out the list of the source and the destination endpoints. So let's go a bit deeper into what is required for us to get Accedian installed and start talking to CNC. So the version that we use in 6.0 for the Skylight Analytics version is 23.11, and it's a light server which uses a single VM. And then the other aspect of that is we need a collector. And from the Skylight Analytics UI, you just enter a few parameters and that will create an image for the connector. And that connector, we can download that. And that Skylight connector is connected using TCP on port 443 so that it can transit firewalls. So in terms of the sensors, we use the sensor agents, which are containers on x86 Linux, but there are also the SFPs, and it's not validated in 6.0, but it is planned for a later release. In the sensor agents, there are also sensor agents that are available in iOS XR, which run in their iOS XR app space, but we have not looked at it. And if there are any use cases, then we can definitely look into that. So looking at the Skylight's analytics server, so it runs on Linux VM, and it's different from the Skylight Analytics, where in the sense the Skylight Analytics, the cloud version has a bigger data storage. It's got dashboards. You can customize the dashboards. But this one has a smaller footprint, where the storage is less, and there's a minimal web UI because most of the processing is done by CNC. And Skylight, the interaction between the CNC and the Skylight Analytics server is using RESTconf, and it's required to establish the TWAMP sessions across the agents that are monitoring the network service. There's also, it needs some certification, client certification authentication, and so that the CNC and the Skylight server can talk to each other. So if CX is also can be taken. So CX can help in installing provisioning agents, and we look at some of the things that are required for making sure the agents are up and running and are connected to the network service. So let's see what a connector is and how we can download it. It's pretty simple. From the UI, say add a connector by clicking on the plus button. You have a few bunch of parameters, not many to fill, and then it creates an tar GZ image. You just download that to a Linux host, and then just you run that shell script, and there you go. That's done. So once we have the agents, the Skylight server, and the connector all installed, let's look at what is required for configuration of the Accedian probes and the connector and on the CNC side. So for the probes to pass for the TWAMP sessions to take the same path as the network service, the probe should be connected to the PEs that the user specifies. And once that is done, it needs information about which VLAN ID it is or which PE it is connected to. That's how it can correlate the agent to the network service that it's running on. And apart from this, we also need information as to which collector it is talking to, and which sub interface the agent is connected to, so that it can talk to PE and the collector. The second step is configuration. As part of the configuration of the VPN, here in our case, in 6.0, we are only focusing on layer 3 VPNs. As part of the configuration of the layer 3 VPN, we can also specify what Accedian topology you would need. And once you specify the topology, then CNC will first configure the L3 VPN. And when the L3 VPN is configured, it also will talk to the Skylight server to establish the TWAMP sessions on the agents, on the sensor agents, so that so you can monitor the traffic across the network service. And CNC automatically subscribes to the GNMI sessions from Skylight, so Skylight then sends all the telemetry information into CNC. So this is a UI which shows the Accedian topology. We will see this in the demo later. We have seen the L3 VPN provisioning portion of that, so we'll just focus on the topology, Accedian topology. So it comes in 3 different types. One is mesh, so then it establishes point-to-point connections across all. The other one is hub and spoke, where then you would specify the hub and then also the spokes, and then it's the point-to-point, then you specify the list of all the source and destination endpoints. Sensor agent setup. So this is where a bit of configuration is required for the sensor agent to talk to the other components. So first one is we need to create an agent and register it in Accedian so it knows. So then once it's created, it gets a UUID, and then we can use that UUID to identify and get the secrets from the Skylight so that the agent can talk to the Skylight. So it's a Docker compose file, and based on your network architecture, if you have a switch between the agent and the PE, then you need to configure that switch. Or for the agent itself, you need to then find the Linux sub interface that talks to the external devices. When everything is configured, you get that Docker compose up, and then your agent is up and running. This is what an agent configuration file looks like. It gives you the information about the container name, the agent, the connector IP address, which is the collector, and then the interface and sub-interface on the Linux host. And the other crucial piece of information that's required is that for the agent to know which PE it is attached to, it needs the ID of the PE and the VLAN ID. And there's a secrets.yaml file. That's how it authenticates with the Skylight server. So we don't need to go into the details of this, but there are APIs. Accedian provides the APIs for us to register the agents, and then when you register the agents, associate the collector that's for the agents using different APIs. This is a get secret, so once the agent is established, to get the secret file for the agent that you can communicate, this is the API for that. So once everything is established, the agents are in place, they have the right information, then CNC will provision the network service and then also use RESTconf to create the TWAMP sessions against the agents that have been specified for that network service. So for the service endpoints, so there is a concept of a service endpoint, and the service endpoint basically binds the agents to endpoints, and then it creates the TWAMP sessions between the service endpoints. So once the L3 VPN is established and we have the TWAMP sessions, then the test data from that is sent through the Roadrunner into the Skylight server, and then through GNMI into the Crosswork data gateway of CNC. CNC subscribes automatically for GNMI telemetry from Accedian. And once that is done, you can filter based on the service ID, or once you do that, then any degradation of the services you will associated with that will be shown there. And it's both shown visually as an assurance graph, and also you get the list of all the affected services or the paths or the subcomponents that have been affected. Okay, so that was a brief overview. Now let's go into the demo. Let's configure a L3 VPN with service health and active monitoring using Accedian probes. The first step is to create an account on the Accedian Skylight. So let's go ahead and create that. So from accounts, we'll choose the users tab. So here we see we have two users, and for our purposes, we will be using the Cisco engineering user. Now let's dig into that user. So it has an admin role, so it can do all the operations. Now, if you want to create a new user, you choose the plus sign, specify the role, and provide the email and the name, and that's it. Okay, so now that we have created a user, let's go ahead and add those user credentials that we created in CNC. So from device management, we choose credential profiles and add the user. So we've already added one. It's Skylight 40. So let's look at the configuration. So here we give a profile name, Skylight 40, and we specify the protocols. So CNC uses REST-conf to communicate with Accedian, hence HTTPS protocol is required. And for the telemetry information to be sent from the probes into CNC through CDG, we use GNMI. So we specify the GNMI protocol and we add the credentials, username and password that we created, and then we save it. Okay, now that's done, let's create the certificates. So there is one Accedian provider mutual authentication profile associated with certificates. In 6.0, you can create one. So we've already created it. Let's look into that. So this requires a set of certificates. The first one is the CA certificate bundle. This is a PEM encoded trusted certificate, authority certificate, used for secure communication between CNC and Accedian. And the next certificate is a client certificate, which is created again by a trusted CA to issue entity service certificates. We also need a private key, and this private key is an intermediate certificate used by CNC to generate Crosswork certificates. Okay, so now that we've added that, the final one is where we add the Accedian instance that we are going to use. Here we kept the same name as Skylight 40. So this is basically where we give a unique name, so provide a name which is Skylight 40. Then the credential profile is we choose the credential profile that we created earlier, and it belongs to the Accedian family. We also associate the certificates that we created for Accedian. Now, for identifying the specific instance, we use the FQDN of the Accedian instance. In our case, it's performance.cisco.com. So now that these steps are done, these are a one-time thing that needs to be done. And once this is done, then we can only focus on the creation and managing our VPN services. Okay, so let's go ahead and create a VPN service. Let's go ahead and create a VPN service. So in our case, instead of configuring the service through UI, we've already created a JSON payload. So let's import that payload. We have imported the payload, and we will look at how the configuration looks like after we commit it, but we'll just look into the probes for now, because in the configuration it's difficult to see all the options that are available for the probes. So here for the probes, it's set on each of the endpoints of the L3 VPN. In our case, the L3 VPN is on node 3, node 4, and node 5. And you can also provide the Accedian topology. We have chosen the topology as mesh, but the user has the option of choosing either hub and spoke, in which case you would specify the hub endpoint and the spoke endpoints. So the user can also choose point-to-point, where the user lists the source and destination endpoints. So now let's go ahead and commit the L3 VPN service. So this will configure the L3 VPN, enable the service health. We have chosen a bronze level service health, and also sets the TWAMP sessions across the endpoints of the probes. So now the VPN has been created. So let's look into the actual configuration of the VPN. So let me just collapse certain things here so as to identify it easily. The L3 VPN is called VPN1, and it is across 3 nodes. And let's look into the details of those. So the first one is on node 3, and it has a VLAN ID of 301. So the VLAN ID of 301 is important because the associated Accedian probe will also have a VLAN ID of 301. That is how we tie the Accedian probe that's connected to the PE. So for the second endpoint of the L3 VPN, it's node 4, and the VLAN ID is 401. And third one is the node 5 with the VLAN ID of 501, and the associated probe will also have a VLAN ID of 501. For service assurance, we have enabled a bronze level profile, and let's look into the probes now. So we have 3 probes, one corresponding to each of the PEs of the L3 VPN. Probe number 1 is associated with node 3, and you see that it also has the same VLAN ID as on the interface of the PE1. Then the second probe has associated with node 4, has equivalent VLAN ID of 401, and similarly node 5, which has a VLAN ID of 501. The Accedian probe topology is mesh, hence the input is null. Okay, so now that this is done, let's look into the VPN. The probe sessions have been initiated, so it takes time for it to get that telemetry, calculate the associated thresholds. Everything is successful. Now, if we look at the monitoring settings, it has a combination of service health, Accedian probes, and SRPM. The first 4 parameters are associated with the service health, and those are the thresholds. The probe delay threshold and the probe variance threshold are associated with the Accedian probes. And the last 3 are associated with SRPM. We see that we have 3 probes, and in a mesh you would see about 5 probes. The reason why we don't have all the 5 and it's not required is because if you look at the first one, node 3 to node 4, node 4 acts as a reflector, so the traffic going from node 3 to 4 is also reflected back to node 3, so hence we do not need probe sessions in the reverse direction. Now here the performance metrics for the probes, all the readings are below the threshold, hence there are no errors that are raised. So let's look at the assurance graph. Path SLA summary shows the graph related to the Accedian probes. So here we see we have 3 of those and everything is healthy. If there are any issues with that, they show up in the active symptoms and the root cause. Let's degrade the service by introducing a delay on node 3. And also let's increase the CPU utilization, so this will see an error for the service health portion. Okay, now that the service has been degraded, let's look into the details. So view details should show that. So there are 3 errors that we see. The first one is related to the CPU utilization, so that's the service health error. And the last 2, between node 3 to node 5 and node 3 to node 4, are because we introduced delays on node 3. So these are the errors for the Accedian probes. Now let's see the thresholds for the Accedian probes. In the forward direction, it has increased the threshold, hence we see that error. And between node 3 and node 5, it has also increased the loss, so we see that error. Let's look at the assurance graph. The assurance graph will let us know the details about which portion of the subservice is affected. Let's focus just on the errored portions of that. So there are 2 errors on the probes, one between node 3 and node 4 and the other between node 3 and node 5. If you dig into one of the probe errors, so it shows that the peer device is node 4. And if you look at the device health for node 3, this is because of the increase in the CPU utilization, which shows that the error, the root cause as heavier than expected resource consumption. Let's look at the assurance graph, the historical view of the service. This is done by enabling show history. It shows the change in states of that service as the events happen over time. This can be used for trend analysis, recognizing patterns to mitigate the service issues. So this is the end of the demo.